Hey everyone, yes, my name is Stephan. I work at Yelp. I'm a backend developer there on the core backend team. So let's get right into it. A little bit about Yelp, maybe it's not so well known over here. Yelp's mission is to connect people with great local businesses. It's a website and an app where you can find these local businesses. We have over 130 million reviews online to help you find just the right business. And our app has currently about 30 million monthly active users. So what will I be talking about? First, what are type annotations and why you should be using them? It's a little bit hard, sorry, with two laptops here. How to incrementally migrate between them, what are some issues that you might encounter, and how you can do type annotations across services. Now, I promise that the first part, why type annotations and what they are, will be very short. I'd also like to mention that I'm by no means an expert on type annotations. I just like them, I use them a lot. And I'll be showing a lot of code to illustrate my examples, so please bear with me. If you're interested in more introductory type annotations talks, there were two great ones at PYCON US earlier this year. Carl Meyer talked about type check Python in the real world. He's from Instagram, really great talk. And Greg Price from first Dropbox, now he's at Zulip, talked about clearer code at scale, static types at Zulip and Dropbox. So let's get right into it. Yes, I hope you can read it from back there. So why Python type annotations? The first example is a little bit contrived. So sure, we say we want a string and we return a string, but then we call the function with an integer. So MyPy will complain, the type checker. I'm going to get into that in a bit. But type annotations are not just for finding bugs, they're also for documenting your code. And so this basically indicates a bug in your documentation, which typically gets out of date. You don't know that your documentation is not up to date. So yeah, this is one good example. The other part is actually a function. Yeah, I'm sorry, you can't read this with the PDF version. It's basically about when you have a large code base, you have functions, they do data processing, and it's super unclear what is that data actually, where is it coming from, what are the possible attributes. It gets even worse if you use dictionaries. You really have no clue sometimes what is that dictionary exactly. And this is where type annotations can help you. So what's our goal? We want to make sure all code is type annotated eventually, and we want to incrementally annotate code because we have a large code base, and we want to make sure that the code that is already annotated, that we run checks on that code and catch any issues. So we want to distribute the task of annotating the code base, and we want to progressively improve the amount of annotated code. And we'll do this on a per file basis. So as people touch a file, we're going to ask them to annotate it. So how are we going to do this? We're going to use the MyPy type checker. Probably many of you have heard of it. It's the de facto standard for type checking. It rapidly improves. It still has some small issues. We're going to talk about that in a bit. But it's rapidly improving, and yeah, this is what we use at Yelp. I want to mention another one, like a newer type checker that recently was open sourced. It's Pyri by Facebook. It's super fast. I think this is the main advantage to MyPy because it can parallelize a lot of the work. It was built for parallelization, and especially if you have like hundreds of thousands or even millions of lines of code, it becomes much, much faster. I'm going to be talking about MyPy since this is what we use at Yelp, but please check this out. So first of all, how do we enforce annotations? I'll be publishing the slides online. I'm sorry for the technical difficulties. Then you can hopefully read the code samples better. This is basically the configuration we're going to use to enforce these type annotations. There's something in there that requires all functions and variables to be annotated. There's a configuration in there that makes sure we treat none correctly, so you actually have to account for the possibility of a variable being none and handle that correctly. And I think this is a good middle ground between like getting the most out of type annotations and not putting too much burden on your developers, because there is like a strict option for MyPy that is even stricter than this configuration, but at that point it can become like really hard to correctly annotate everything. So now that we know how to configure MyPy, how do we make sure it gets run? For that we use pre-commit. That's an open source tool that actually we at Yelp open sourced a while ago. It kind of like has the concept of hooks that you run on each commit on all the files that the developer changed. And there's like many hooks for a lot of different languages available. The Python support is really good because we are using a lot of Python. And so let's get right into it. How do you configure a pre-commit? Basically, we ask pre-commit to run MyPy with a special configuration option where we point it to the config I just showed you a few slides earlier, and we're going to use that to check our code. All we need to do is make sure that everybody has pre-commit installed. So typically you do that when you run your tests or as part of like some sort of make step in your project that developers need to run. And this is what it looks like. So there's a sample output. You can see there's like a bunch of different hooks that we have, and there's many more available, like I mentioned. In this specific example, I modified a file media.py, and the pre-commit hook informs me that one argument to a function is of incorrect type, and that I'm missing a return type annotation, and also actually an annotation for another argument. Now, note that this is not a foolproof solution, so developers can skip individual hooks or like all of pre-commit, but unless your developers do that, I think this is a pretty good way to make sure things like that are enforced. So, but you want to run MyPy as part of your test suite as well. In that case, your primary goal is not to make sure that people annotate the code, but to catch any issues with the code that is already annotated. So this is using a less strict config. It's okay to not have annotated code since we're running this on all of our code. Just to mention here, the problem is that once you hit a function or a method that's not annotated, this is where like the MyPy checking stops. So in the beginning, you're going to notice that as you start annotating, you don't catch a lot of issues. You just have to keep going, and the more you annotate, the better it is. And then you're going to really start seeing an uptick in issues being caught. And the other part of annotating, which is documenting your code, that benefit you get immediately. Now, since it can become tiresome to manually annotate everything, there's tools, finally. Now there's tools to help you with that. Probably the best one is Type, which is by Instagram. You can run it basically as part of your normal code execution, and it will generate type information or gather type information, save that in a special file, and then you can use that to automatically annotate your code. The other one mentioned here is PyAnnotate. We've tried that as well from Dropbox. It's also pretty good, but it only supports like the Python 2 style annotation, so in comments. So unless you're on Python 2, I'd really suggest using Type. One thing that you need to be aware of, this is not like you run it once and you're done. The annotations won't always be correct. Sometimes they will be too strict. Sometimes they will just be plain wrong if you run monkey type as part of your tests. Like you'll see annotations with mock objects in there. Like a developer needs to double check them and fix them, but it's a great way to get started and remove some of the burden. So one of the most important things about type annotations is, like I mentioned, type your data. You really want to know what type your data has, what you have there that you're passing to a function that you're returning. A lot of bugs happen, like I mentioned, because opaque dictionaries get passed around and people are not really sure what's in there. It can get even worse when people mutate those dictionaries. So you get like your business dictionary, and then you have a function and it adds something to the dictionary, or even worse, it removes something from the dictionary, or it changes the value of a field in the dictionary. It's really hard as your code base grows to work with these data structures. A really good way to annotate your data is to use named tuples everywhere. Not only can you type them now with Python 3, but they are also immutable, so you can't just willy-nilly change them once you created them. It requires some developer effort, basically creating a new version of that name tuple. So I think they work really well. Sometimes, though, you can't or you don't want to convert to name tuples. So MyPy has you covered there as well. There's a type dict type in MyPy that you can use, and you can use that to annotate your dictionaries that you pass around as function arguments, for example, or that you have as variables. Unlike maps, hash maps, or whatever in other languages, you can have different types based on field names. So not everything needs to be the same type. So just creating this annotation object can really help and catch a lot of issues. I know this is probably like really hard to see, but we have a bug here where we use this business dictionary and we use the get method to get the field address to, and if that field is not present, it returns an empty string. Now the bug here is that I mistyped address to. It only has one D instead of two. So this will always return the empty string. And the insidious part of this bug is that this will not cause an exception, not even at runtime, since I used the get method. It's just a logic bug. It's really hard to find. And if you write a test for it, hopefully you do write the test correctly, because if you mock the data in a wrong way, then the test is not going to catch your issue. MyPy will warn, like that's the error message down there. MyPy will tell you that this is a problem and that you need to fix your code. So, but hopefully I've convinced you that named tuples are even better than typing your dictionaries. So how do we use them? One way is to have a small helper function that takes a dictionary, a named tuple class, and converts that dictionary to the named tuple class. This works. We actually use that in our code base, and basically, as long as you have defined your name tuple, which is basically the same amount of work as defining your your type dictionary, you can just call this function, and your dictionary will become the name tuple. We consider the name tuple definition the source of truth of the fields that your data has. So all of the fields in the name tuple, it will copy over from the dictionary. Anything that's not in the name tuple definition will be lost. And this works. So should be easy enough to annotate that function, right? It turns out you can try to, if you try it like this. Basically what I did was a naive approach. I said, well, NT class is a class, so we need to use like type of name tuple. We can't just say name tuple. And it returns a name tuple instance. The problem is it will, like you see, there are two errors. The problem is that we care about what name tuple instance we're returning. We can't just say name tuple we return a specific thing, and if we don't say what specific thing we're returning, like for example the business name tuple that I showed you earlier, type annotation later on would fail. So we read about generics and how to use them. I create here like a type var named struct. It says bound to name tuple, so it means the base. The base requirement is that it conforms to name tuple, and I'll use that. Unfortunately, this doesn't work either, since name tuple is not actually a class. It's a class constructor, if you will. So you pass it some arguments, and on the fly it creates a class definition, but there is no actual name tuple base class. So this is why generics in this case won't help us. MyPy has some special handling for name tuples, but still this is not supported, and this won't work. So what do we do? The solution is protocols, something that was introduced, well, relatively recently, and works really well. Basically, protocols are duck typing. So you describe behavior and don't say like, hey, this is the base class or this is the base type. You just describe behavior, which is exactly what we want here, because all named tuples have the same behavior. So in our code that we're trying to annotate, we're kind of like using the underscore fields. We're using name tuple underscore make. Every name tuple has that, but there's no base class. So we need to describe that behavior. Actually, the common base class of all named tuples is just tuple. There's nothing in between. So so these protocols, you should really check them out if you have code that previously you weren't able to type annotate. They're similar to interfaces in Go or protocols in Swift, and they solve a lot of the use cases that previously you weren't able to annotate correctly. One more thing about named tuples. They do have count and index methods. All of them have them, and this is actually because they inherit from tuple. It's actually tuple methods. So defining, and these are like pretty common names for attributes, I would say. So using them will cause MyPy errors, because MyPy doesn't allow you to redefine them. I'll just like to point this out here. You can kind of like type ignore the errors. The name tuple will work as expected. You just can't access the tuple count and index methods easily anymore. So one more thing I'd like to mention as you progress to like annotating your code base and go beyond the introductory part of like, hey, everything works, everything is great. Maybe you have a descriptor or two in your code base. So an object that kind of like manages how an attribute of another object is accessed. In this case, this is an example again. Hopefully later on, when you check out the source of the slides, you can read that better. But basically, we use generics here. We have a type for the object, which attribute we're managing, and the type of the value, and we're kind of like using that down there and basically saying, hey, this is a set once property of BizApp context, which is the class that holds the property, and the biz user ID is an int. So if we do all of this, MyPy will know that biz user ID, yes, it's a descriptor, but the type is an integer, and it will catch issues if you do that. And very hard to read, but there's an open GitHub issue about actually documenting how to use descriptors with MyPy. So if you're interested in doing that, please check it out. Another gotcha that you're going to hit, if you have any sort of tree-like data structure in your Python code base, this is going to be a problem. MyPy limitation is that you cannot use like recursive typing. So when you type an object, obviously in this case I used the name tuple again, and you want to like reference itself, this doesn't work, which means that like your tree-like data structures will mostly be untyped. You can work around this a little bit when you have like functions that work with these data structures, and you can use the MyPy cast operator to re-add the type information, but you have to remember to use it everywhere, and obviously there's the chance that you're going to introduce bugs or that you're going to forget to do it. There's also an open GitHub issue, and this is a larger issue, so it's being worked on, but I'm not sure how soon this is going to be fixed. And since I mentioned Pyre, I'm not sure what the status is. Maybe Pyre supports it. Unfortunately, I don't know. So let's talk about the second part of my talk. Now you have your code base annotated, but since we're talking about larger code bases, and you have maybe this big legacy code base, chances are that you have started to invest in a service-oriented architecture, like we at Yelp have. I know a lot of other companies have as well. And I've spoken in the past about how we do services at Yelp and the challenges it poses in regards to reliability and testability with these code bases that get like developed and deployed independently, but still like interact all the time with each other. So the question is, can type annotations help us add a little bit confidence to that when we do like a change to one code base that it doesn't break another, or when we call one service that we're calling it correctly? Just to illustrate what I'm talking about, it has colors in the original. So our code calls other services, and how can we make sure that like we treat the data that gets returned from that other service correctly? A typical way to do this is to write end-to-end tests. So you kind of like spin up real instances of all of these services, of all of your dependencies, and then you write a test that executes these code paths. These tests are costly to run, sometimes hard to write, and like these other services you're calling, they might have dependencies as well. So at some point, this might become like unfeasible to do for everything. So people try to get by with unit tests, and we'll see how that works or doesn't work in a bit. And let's look at how a service call works at Yelp. So every service has an API specification, a document in JSON or YAML that describes all of the endpoints, all of the data you put in, and the data it returns. We use OpenAPI. I know there are like other solutions. And for each service, we generate a Python client library that incorporates or that knows about the spec. It has a bundled version of the spec, and like has a nice Pythonic interface so that you actually, it looks like you do method calls and things like that, and all of the work of doing network requests and serializing and deserializing data, all of that is taken care of for you. So the question here is, in this setup, can we provide some form of like compile time checks, so static typing checks that help us make sure we reduce the number of issues or bugs we have when doing these like distributed architecture? To understand it a little bit more, one example of an endpoint definition, shortened one, we're going to use this as an example. So this is an endpoint. It's a GET request to fetch some business information, and the response references some form of object. So let's take a look at that. I hope you can read that. It looks actually like very similar to how you define a named tuple or the type dict. Yes, it's a little bit more verbose, but more or less it's the same. One thing I'd like to point out, I don't know if you can read that, there's a field review rating. It's like the aggregated rating of a business, and the type is string for historical reasons. So you'd expect it to be a float, but we transfer it over the wire as a string. In Python, in earlier Python 2 versions, there were like sometimes issues with floats, so that's why we use the string here. And this oftentimes trips up developers because they expect it to be a float, and I think nowadays there's no real reasons for it not being a float unless for backwards compatibility. Yes, and in the open API terminology, like these data objects are called model or data models. So I'm going to be using that from now on as well. Now, to wrap this up, let's take a look at how we make a service call with these client libraries. We have this create client call that returns this client object, which according to the spec will have dynamic attributes and methods to make these service calls as defined in the spec. If you change the spec, so changes this client object. And we can see here we do client.business.businessinfo. The .business is just the first part of the URL, and the business info, the .business info, that's also defined in the spec. That's the so-called operation ID. Now, since end-to-end tests are hard, let's write a unit test to test our code. Notice that we've annotated our small helper function, getBusinessReviewRating, to return a float, since that's what we expected to return. And we've written a test. It's really hard to read, but it uses a mock object that sets the review rating to a float. We then assign it to this client. Like, the syntax is a little bit unwieldy, but that is basically how you set the client return value. And then we assert that the review rating is the same as the mock's review rating. This test will pass, but the code won't work in production, because as soon as you treat whatever this function returns as a float instead of a string, you'll get an exception. So how can type annotations help us fix this issue? Here's the general architecture of what we can do. So we have this API spec in YAML or JSON format. I've shown you how the types in there really correspond very well to what we have in Python, which makes sense since over the wire we use JSON, so everything you have in JSON you can represent in Python as well. And we'll take that spec and we create so-called model stubs. So basically these annotated, like type annotation objects for these data models in the Open API spec. And then maybe we can also find a way to, like, that really dynamic client object to fully type annotate that as well. But let's focus on the easier part first, on the model stubs. So here is the corresponding definition of the data model I showed you in Open API. I know it's hard to read, but basically it's the same fields with the same types. And review rating has a string because the goal here is to auto-generate these. We don't want developers to create them manually. It's obviously possible, but since we have the spec and there's like a really good mapping, we can just write some code to take the spec and create these type annotations automatically. What developers still need to do is, once we have these annotation objects, to use them in the code. So use them as type annotations in the code. That's a manual step. Maybe we can fix that as well, but for now, developers will need to do that. So let's look again. Like, this is actually the same function just as before. All we did now is to replace the mock object we used to kind of like represent the data the service sends. We replace it with using the actual like model type annotated object that we auto-generated. That's the only thing we changed, and we set again the value to 4.5, the float. And MyPy will catch this error because MyPy knows the type of each of the fields in this business object and says, hey, the argument 1, the review rating, is a float. It's supposed to be a string. So all of a sudden, by just switching to using these like annotated models in tests, the test becomes much more valuable. So, but this, again, can, this can be a little bit problematic as well, or tedious rather. You have to like use that in tests. You have to not forget to use it in tests. You have to manually use this annotation. So can we actually annotate that client object that is based on the spec? Can we actually do that? And it turns out we can. Just for reference, above there is like how we use the client, how we make use of it in our code that runs in production. And this is like the generated annotations, shortened obviously, based on the spec. So this business service client, that is kind of like the generated type stub for the client object that we have in our code. It has one attribute, business, that is a business resource. What is a business resource? Well, it's also just some class that has a business info method, and that is fully annotated. So it says, well, it has one argument, business ID, which is an integer, and it returns something called an HTTP future, which is a generic class, which is defined below. And to make it a concrete class, we pass it the value that's going to be returned by the result function. Now, might not be like obvious immediately, but this basically works, and it makes sure that when we do client.business.businessinfo.result, that MyPy fully knows what this .result, what the type of that is. And that type of the .result will change depending on if you do client.business.businessinfo or client.user.userinfo or whatever. So this is fully annotated. Developers don't have to kind of like annotate these data models as well. So the business in HTTP future business, that's actually our generated typed model stub. And this goes as far as that like modern IDEs, like for example, PyCharm here, they will find these annotations and they will provide you with code completion, and you can basically find issues as you type. And all of this is checked and verified before you wrote a single line of test code, just with type annotations. And again, over network boundaries. So, takeaways here, annotate your code to improve documentation. This is really a big one. I cannot stress that enough. It will also help you catch bugs earlier, but the documentation alone, plus the fact that if your code changes and you don't change the type annotation, that you will get an error potentially, this really helps in making sure the documentation stays up to date. Type your data with fine-grained data structures, like I mentioned. This really helps understanding larger code bases. Yes, it potentially reduces the number of tests you have to write. I'm not going to argue, hey, throw away all of your tests, but there are some tests, especially when you test code that does network calls, that have really low value, but still are not super easy to write. I would say it's much better to replace them with intelligent generated type annotations. Yeah, and make sure, like one thing I would mention is make sure that you communicate early and often with your team, that everybody is on board with putting in the additional work, because it is additional work to type annotate your code. So make sure everybody is on board, because if people are not on board, they will find ways to get around the checks you do, and they will write annotations that silence MyPy, but don't really capture what the intended type is. There's, for example, the any type, anything is any, so people could use that, and you basically lose all type information, so you want to make sure everybody's on board and convinced that this is valuable. So, if you want to know more about Yelp, these are some resources. I'd especially encourage you to check out the engineering blog, which has, I think, some really nice articles. Also, we are hiring. I am working out of the Hamburg office, Hamburg in Germany. So, if you're interested, come talk to me, or find us at one of the resources I mentioned earlier. Thank you.
Stephan, thank you for your talk.
Any questions?
Now time of questions. And again, we have still books. Okay.
Thanks for the talk. I have a question about compatibility of type annotations and Python duck typing. For example, we have a library which deals with numbers. Oh, so objects with have interface of numbers, integers, floating points, and decimal. So if we type annotate with only int, all other types are sliced. What we can do with this situation? Can we more flexible point type annotation to avoid this? Thanks.
Yes, thank you. That's a good question. That's exactly a problem that you're going to encounter. We use duck typing in Python, and it has many advantages, but it means, like you say, you can't just say, hey, this is an int. There's two ways that I know to deal with this problem. One is use protocols. They seem a little bit intimidating, but hopefully you can capture the behavior of all of these numbers and then create this protocol and then use that as your type annotation. The other way is sometimes you will need to refactor your code to get value out of type annotations. So we've had functions that kind of take a string or an int, and then if that string can be converted to an int, then convert it to an int, otherwise return the original string, or sometimes return none. And you can try to figure out an annotation that somehow captures all of that, but that function is so dynamic and it does so many different things, only depending on the type and value of the input data. It doesn't really make sense to have such a function with type annotations, or put another way, you'll have some very loose type annotation that doesn't provide you with lots of value. So, short summary, check out protocols. If that doesn't cover your use case, you might have to look into using very loose typing.
Thank you for a great talk. You mentioned that you use auto-generated type annotations for your services clients by OpenAP specs. Do you use some open source library, or you have your own custom solution for that? Thank you.
Sure, yes, great question. So unfortunately, that solution is not open source yet. I hope we can make it open source. We do have an open source client for OpenAPI, which is called Bravado. There's actually a whole range of libraries for Python that we maintain that you can use. Unfortunately, the type annotation generation is not in there yet. Our Python client libraries are basically a wrapper around Bravado. So I hope in the future I can provide that. But for now, it's a custom solution, and we're actually working to use that more and more. So we're also looking into creating, for example, classes for our mobile apps in Java and in Swift based on API specifications, which is kind of the similar concept.
Hi.
Hey.
Thanks for the talk. And when you in Yelp decide to do type annotations, do you think of other solutions like rewriting static typing language? If yes, did you try it? And why the final choice was type annotation?
Yes, good question. Definitely, whenever you start using type annotations, a good question to ask is why not use a statically typed language in the first place? For us, the problem is really twofold. We have lots and lots of Python code, so it would be a huge undertaking. And you know how it is when you rewrite big parts of code, there's a big risk of introducing bugs or behavior difference. And the second one is also the skill set of our developers. So while I'm sure everybody can learn new languages, we have a lot of people that know a lot of Python. So those two things taken together make us look into type annotations.
Thank you for your talk. My question is related to your last slide where you mentioned the importance of having everyone on board before you move on with type annotations. Have you encountered much resistance to type annotations? And the second question is, have you monitored, for example, the amount of bugs or tickets that are incoming as you're performing this type annotation introduction? And has there been any trends? Thank you.
Unfortunately, to answer your second question, unfortunately, I don't have hard numbers, so neither on how much additional work it is, nor how many issues does it catch. Like that thing is really hard to quantify, since it's just something like people encounter in when developing. We do have like anecdotal evidence, like we do postmortems at Yelp, and we did have several based on the fact that distributed code gets deployed and then doesn't interact well with each other. Unfortunately, we don't really have a test suite that really spans lots of services. So especially when you modify like the lower layer of services at Yelp, it's like you really need to be careful and make sure like you only do 100% backwards compatible changes, because probably no test suite will catch that issue otherwise before you go to production. Could you maybe repeat the first question? I didn't fully get that.
My first question was, did you encounter any resistance to introducing type annotations in the source code base? And how did you overcome it, if you did?
Yes, very good question. At Yelp, I haven't, like people were actually very enthusiastic about it. And even like, for example, our front-end developers also like really embracing type annotations and are using similar solutions for JavaScript. And at least from the two talks I mentioned at PyCon US, I think at Instagram and Dropbox also people were very enthusiastic. So there might be people that don't like them, but I think when you work with these, you have to see, like, you might like the concept of Python and the way the language is, but as soon as you, on a day-to-day basis, deal with like a code base of millions of lines of code, you really run like into these pain points of not really knowing what it is, that data object that you deal with. So at that point, you still like the simplicity of Python, but in that code base, you want to know the type. So I think that's why people have been mostly enthusiastic.
More questions? Okay, thank you for your talk.
Thank you very much.